In the late 60s and early 70s, researchers at NASA learned quite a bit about living and working on other worlds with the success of the Apollo moon landings. These missions helped broaden our understanding of how humans can work and interact outside of the comforts of Earth. But even though much was learned about problems astronauts would face on other worlds, the human presence on the moon was relatively short, generally only a few days at a time. Future missions to Mars will be much longer, potentially lasting years at a time. Things that many of us take for granted, such as food, clothing, medical care, and safety, will be some of the biggest challenges that need to be addressed by NASA planners. To help us understand what is being done to prepare for these long-duration missions, I spoke with Lisa Guerra at NASA headquarters to find out how it works.
The major challenge to live and work on other worlds is predominantly adapting to a new environment. The crews will be coming to these new worlds, and the one we've been looking at in particular is Mars, and have to arrive and adapt to the environment. And that environment on Mars involves a third of our Earth's gravity, as well as different weather patterns, dust storms, which we are particularly concerned with, radiation, which we have to measure and understand how to protect the crews against. And in particular, these crews will be traveling for long distances from Earth to Mars, and we will have to have the crews fend for themselves once they get there. There will not be hosts of doctors and NASA personnel when they arrive, and so are they physically able to adapt to this environment as soon as they get there.
So when our astronauts arrive at Mars, will they have to build permanent bases, or could they just live on the spacecraft that they arrive in?
Whether they live in their spacecraft or we would have to have a more permanent habitat for them would depend on how long they would stay at Mars. And there are two different approaches to sending crews to Mars. One involves a short stay, and that's on the length of about 30 days on the surface of Mars. If that's how long they would be there, they could probably live out of their spacecraft, much like the Apollo astronauts did. However, if we take the other approach to going to Mars, they could be there for almost 500 days, from a year to 500 days in Mars vicinity. And in that case, it's a very long time for 6 people to live out of one spacecraft, so we would probably have a larger habitat and presence on the surface. It would also mean we'd probably need other power sources than solar power, because they'd have to sustain their activities for such a long period of time. And with the weather and dust conditions, it makes solar power very difficult on Mars.
So Lisa, when astronauts are on Mars for years at a time, how would they get their food and water?
As I mentioned, if they could stay for over a year, ideally you could use some of the resources that might be on Mars. And with our current Mars robotic program, we are trying to determine the levels of potential water or water ice on the planet. And if we do find sources in large quantities of water, we could use that for the crews, as well as use it in fuel cells for power generation. We could also use the atmosphere, which is made up predominantly of carbon dioxide, and you could use methods to decompose the carbon dioxide into oxygen, and then we could use that oxygen for the spacecraft air. As far as food goes, again, if you have water and oxygen, you could ultimately see the crews developing their own growth chambers and actually growing their own food. And that would be something we'd look into if we were staying there for a long time.
What are some of the differences astronauts might face, working on the moon compared to working on Mars?
The difference between spending and occupying time on the moon to Mars, first and foremost, is that the moon is much closer to the Earth, about a 3-day trip. We could actually rescue the crews if necessary. They could come back and get medical care. They would not have to be as self-sufficient, and you could set up like a ferry system with logistics, much like we do with the space station. So again, the crews could operate for varying amounts of time, but still be reliant on the Earth. Whereas the distance to Mars is so much greater, we'd have to build the reliability and maintainability into our systems and have the crews be much more self-sufficient. Right now, NASA is planning to use the moon as a test bed for Mars. This would be primarily a systems type test bed, design some of these life support systems and spacesuits and use them and work them on the moon and learn from that engineering experience and then improve the design for Mars.
One major challenge that will need to be addressed will be what type of spacesuit our astronauts will wear on other worlds. The current suits used on the shuttle and in the space station work well, but they are not designed for full-range motions like walking and working on a planetary surface. So future suits will probably look more like the suits that were used during the Apollo program. These new suits will need to be much more durable and better suited for the harsh conditions astronauts will encounter on other worlds.
The other issue, though, with spacesuits for Mars is the dust issue. The dust tends to be very electrostatic, and there are concerns that if you came into the habitat or the airlock with your suit, that dust would get circulated into the air system. So there are concepts being developed where maybe the suit never comes into your habitat, that you actually step out of it, like walk out from the back of your suit into your habitat, and the suit's always exposed to the environment. We're looking at this as not just a milestone, but a journey to actually get beyond Earth orbit, to get beyond the moon and go to other worlds. And so everything we do today and everything we expect to do in the next couple of decades will give us a capability to enable us to get to Mars. And it may not be within my career, but it may be the young engineers in school today, that they will see it through, and the next generation and the next generation.
So that's how it works. So for the next generation of explorers, a walk on Mars might be in the cards. And with my pull here at NASA, I just might see you there.